Hello everyone, I am Dharmendra Kumar Chaudhary, Assistant Professor in Department of Textile Chemistry at MLVTEC Bhilwara. Now, in our online lecture series today, in this video we will study about the high temperature, high pressure dyeing process of polyester fabrics. Before starting to this lecture, we just summarize what were studies in the last three lectures. In the last three lectures, we discussed about the basic concepts and basics of the polyester dyings, and in just last lecture we studied about the carrier dyeing method of polyester fabrics. In carrier dyeing methods, we use a carrier and the dyeing temperature is around at boiling, because carrier swells the fiber and also reduce the glass transition temperature of the fabrics. That's why polyester fabric can be dyed at boil. In high temperature, high pressure dyeing method, the dyeing of polyester fabric is carried out at around 130 degrees centigrade temperature. This method is one of the most popular commercial batch-wise method of polyester dyeing. This method is based on opening of fiber structure at higher temperature and generate lesser waste water load, because in this method we do not use carriers. That's why the effluent load generated due to carrier is not applicable in this method. In this method, as temperature increases, solubility also increases, and higher the affinity due to more solubility of dye as well as opening of fiber structure. Equilibriums are achieved through a balance in all the dyeing steps, that is, dye dispersed in bath, dye dissolved in bath, dye absorbed on fiber surface, and dye diffused in situ fibers. It means as you increase the dyeing temperature, then the solubility of dispersed dye is increased, because solubility of dispersed dye is higher at higher temperature. As solubility is increased, simultaneously, due to more solubility of dye, affinity of the dye towards the fiber is also increased. So ultimately the penetration of dispersed dye on fiber structure is increased, as increasing the temperature via two things. One, as temperature increases, solubility increases, as well as at higher temperature opening of the fiber structure is more, so the penetration is also facilitated by more opening of the fiber structure at high temperature. Now we discuss about the strike rate of the dyeing. Strike rate is proportional to increase in temperature. At 117 degree centigrade temperature, all existing dispersed dye complete exhaustions. Means at 117 degree centigrade temperature of the dye bath, the sufficient amount of opening in fiber structure is happened. So at this temperature, the exhaustion of dispersed dye is completed. But technically 117 degree centigrade is sufficient for a level set, but in commercial purpose we take another increase in temperature, that is about 10 to 12 degree. That's why we say dyeing of polyester fabric with high temperature high method, high temperature high pressure method is carried out at 130 degree centigrade, because at 117 degree centigrade is technically, we say, at this temperature sufficient amount of opening is happened, so dye will penetrate easily. And again, and after 117 degree centigrade dyeing temperature, we increase 10 to 12 degree further to ensure the uniform distributions and ease in migration of dye to compensate heat loss during dyeing. Leveling of shades in the dispersed dyeing, in the high temperature high pressure method of dispersed dyeing, layering of shade is crucially varies with the control over the temperature. Much of exhaustion takes place between 100 to 120 degrees centigrade. That's why So efficient control over the temperature is needed during heating in the range of 100 to 120 degrees centigrade, because at this temperature range, the amount of exhaustion is maximum, that is around 80% of the total exhaustion. So we need much controlled rate of dyeing, and this is controlled through controlling the temperature. Means how you increase the temperature, means the rate of temperature increase, that is per minute increase in temperature. Generally we follow 1 degree centigrade per minute increase in temperature. After dyeing, in the disperse dyeing, there is a one common problem which is associated in this method, that is formation of the oligomer formations. So at high temperature there is oligomer formation, but when we drain the bath after cooling, if we drain the bath after cooling, means at around 80 degrees centigrade, then the oligomers are deposited on the fabric surface. If we need not presence of oligomer on fiber surface, then there is one option. If you have choice, if you avoid the problem of oligomer for deposition on surface, then you need to drain the bath at 130 degrees centigrade or up to 120 degrees centigrade, because at this temperature the oligomers are generally not deposited on the fabric surface. They can easily removed with the dye bath. But as you cool the dye bath, then it deposited on the fabric surface. So if possible, if your infrastructure permit you, then you can drain the dye liquor or dye bath at higher temperature as possible. Otherwise you should cool and drain the bath. After dyeing of fabric, dyed fabric is treated with the 3 GPL NaOH and 3 GPL Na2H2O4, that is hydro. In our the popular language of the processing, we called caustic and hydro at 60 degrees centigrade for 10 to 12 minute time to remove the superficial dispersed dye from fabric surface. So after doing reduction clearing treatment in short form, that is called, it is known as RC treatment. So after RC treatment, we can assure the better washing fastness by assuring the absence of superficial dispersed dye on fabric surface. Now we will just see the dyeing profile of dispersed dye with high temperature, high pressure method. In high temperature, high pressure method, we start the dyeing at 60 degrees centigrade, as you see in this graph. From 60 degrees centigrade to from 85 degrees centigrade, that is around just near around the glass transition temperature of the polyester fabric. The glass transition temperature of the polyester is around 80 degree. So we increase the temperature from 60 to 85 degree with high rate, means the increase from 60 to 85 is maximum rate of heating rate is heating rate is higher, because up to 85 degrees centigrade, our preciously we say just near about the glass transition temperature, there is no dyeing, because there is the sufficient opening which is required for dyeing is not present here. That's why we increase the temperature with the maximum rate of heating. After this point, up to 120 degrees centigrade, we increase the temperature very slowly, that is around 1 degree centigrade, per minute. Because in this region the maximum opening which is required for dyeing is carried out. That's why we control the rate of dyeing through controlling over the temperature of the dye bath. After this point we increase the temperature with higher rate, because up to this point sufficient opening which is required for dispersed dye particle to penetrate inside the fiber structure is happened. So that's why we increase the temperature with maximum rate. Again, after 130 degrees centigrade, we hold the dyeing for 30 to 45 minutes. It may be lesser than 30 minutes, it may be higher than 45 minutes. That is depend so wholly on the percentage said. So as we see, this increase in the temperature is much higher rate, because it is not much affected the exhaustion of the dispersed dye on polyester fabrics. It just provide the leveling of the shade as well as proper migration of the dye particle inside the fiber structure. After 130 degree centigrade, we cool down the dye bath up to 80 degree centigrade temperature, and then drain the dye bath. If your facility permit you to drain the dye bath at higher temperature, then it will give you a extra advantage, that is oligomer deposition is avoided if you drain the dye bath at high temperatures. So we just discuss about the high temperature, high pressure method of the disperse dyeing in this video. This method is one of the most popular and most most commercially accepted in the batch-wise process of polyester dyeing. In this method, you can dye the polyester fabric as well as polyester component of the any blended fabric efficiently. Now we will discuss about the thermosol dyeing of the polyester fabric. So in the thermosol dyeing of the polyester fabrics, we just say this method is continuous method. This method is continuous method. In this method, dye is transferred. Dye is forced to get sublimized in solid fiber phase through partial loosening of intermolecular bonds under heat treatment, when the internal structure of the fiber opens up to allow dye molecules to diffuse at the interior. This process is of non-migrating types. It means there is no further scope of the labeling. Once dye is transferred from its solid phase to fabric surface. After transferring, there is no migrations. So we need more accuracy in this dyeing method. So exactly what happened in thermosol dyeing method, we just discuss in a very simple language. First, dye is deposited on the fabric surface as possible as with maximum uniformity, and then fabric is dried to avoid the migration, and then the dispersion, the dye particle which is deposited on the fabric surface, this surface is subjected to the further curing, means at temperature 180 to 200 degrees centigrade. At higher temperature, dispersed dye has property to sublimize. So dispersed dye particle which is deposited on the fabric surface is diffused inside the fabric structure at temperature around 200 degrees centigrade. So now we will discuss this method. This method is much suitable for the polyester cotton blended fabrics, because when we pad the fabric, so because polyester has a less absorption capacity, so we need along with polyester there should be other component which have capacity to hold the dispersion of the dye. That's why it is not preferable for pure polyester fabrics. If you dye pure polyester fabric with thermosol dyeing, then there may be issues of the leveling of the dye, there may be issue of the migrations, patchy dyeings. Again, if you need to do thermosol, if you need to do polyester dyeing with thermosol, then you should assure multiple dips in the dye liquor. So one of the most important property of the dispersed dye which is considered in the thermosol method of the dyeing is sublimation property. Sublimation of dispersed dye play a great role in this method. For thermosol process, poor to moderate sublimations and accident diffusion coefficients are required. Now we discuss thermosol process. How we dye polyester fabric with thermosol dyeing. So before dyeing, we should ensure that fabric is properly pre-treated, uniform absorption. Then we start the dyeing. So pre-treated polyester cotton blend, our other fabric is padded with the liquor containing dye, dispersing agent, acetic acid at 70 to 80% expression, followed by IR drying. Generally, IR drying is generally preferred for drying at 90 to 100 degrees centigrade for complete drying of padded fabric. During this process, we should ensure we should avoid the migration of the dye and uniform deposition of dispersed dye dispersion on fabric surface. So we should place IR heating system just after the nip of the padding angle. So the passage after the nip to contact of heat on the fabric surface is minimum. So in this minimum passage, fabric take minimum time to dry. So migration, our non-uniformity of the dispersion on fabric surface is avoided or minimized. Then the dried fabric passes through stanter, our curing chamber, our loop edger at 180 degrees centigrade to 200 degrees centigrade for 60 to 45 seconds. Again, the temperature is depend on class of dispersed dye and very preciously sublimation property of dispersed dye. For complete diffusion of dye in partially or fully sublimized states. So we just discussed about the thermosol dyeing method. Before discussing thermosol dyeing method, we discussed the carrier dyeing, high temperature, high pressure dyeing, thermosol dyeing methods. Each and every method have some limitations and some advantages. So in our online lecture series, we completed the dyeing of polyester fabric with dispersed dye. Thank you very much.